This is the second part of 2.3, biconditional statement. Before I start this video, I want to let you know that I'm not going to write down everything just for the sake of shortening the videos. So please make sure that you pause the video and make sure you write out the entire statements in your notes, and that way it will help you to learn. This part is not difficult. However, if you don't understand it, sooner or later you're going to get confused. So I really strongly recommend that you make sure you fully understand how we make these logical reasonings in this unit so that you won't get confused. Okay, now let's start. A biconditional statement is the conjunction of a conditional and its converse. So let's write that down. So it's the conjunction. Remember, conjunction is simply to join two statements together with an and, right? A conditional and its converse. So we have to, in other words, we have to find a conditional statement and we have to find its converse. And the symbols are here. The first part is a conditional statement. If P, then Q. Second part is this converse. We swap the P and Q, but the conjunction is, remember this from the last unit, it's and. So when you put everything together, you say, you can either use this long form that say, if P is true, then Q is true. And if Q is true, then P is true as well. However, we can shorten this into this symbol, and it's reading as if P is true if and only if Q is true. I want you to pay special attention to this keyword, if and only if. So everything before that statement is true. Everything after that statement is, everything before that statement is my P. Everything after that is my statement Q. Okay? So also, finally, biconditional statements are true when both the conditional statement, conditional, and its converse, condition, I can't spell, conditional and converse are true. All right. So here are some examples. What's given below is a biconditional statement, and you're asked to write out the conditional and the converse statements as well as make a conclusion of its truth value. So first example, two angles are supplementary if and only if. Here is my Q. The sum of their measures is 180 degrees. So the statement before the if and only if is P. The statement after that is Q. So my conditional statement says if P, then Q. So if two angles are supplementary, then the sum of their measures is 180 degrees. And again, here right after if, this is my P, then is my Q, and this is my conditional statement. And my converse is simply swapping the P and the Q. So if the sum of the measures, or the sum of two angles, is 180 degrees, then if the sum of the two angles measures is 180 degrees, then they are supplementary. And in this case, the truth value is true because both are true. Here's my second example. I wear my snow boots if and only if it snows. Here's my keyword. So P is in the front, Q is in the back. Conditional statement, if P, then Q. So if I wear my snow boots, then it snows. And my converse is the opposite. I switch the P and Q. So if it snows, then I wear my snow boots, right? And the truth value in this case is false. Why is it false? Remember, biconditional statement has to be true when both its conditional and converse is true. So in this case, the converse is true. If it snows, then I wear my snow boots, common sense. But the opposite is not necessarily true. If I wear my snow boots, then it snows. It could be Halloween. It could be I'm trying my snow boots on. It could be that I don't have any clean shoes. I'm wearing my snow boots, or just keeping myself warm. So the first conditional statement is a false one. Therefore, the truth value of the biconditional statement, which is this one, is false. And all we need to say is conditional is false. Another example, x squared equals 25 if and only if x equals 5. So here's my Q, and here's my P, here's my Q. Conditional, if P then Q. So if x squared equals 25, then x equals 5. Converse, switch the P and the Q. If x equals 5, then x squared equals 25, right? So in this case, the second one is true. The first one is false because x can also equal -5. So the truth value, therefore, is false because conditional is false. Okay? So give number 4 a try on your own, and the truth value of that is true because both are true. And here's a summary of all the logic statements that we have learned so far. And this is a really good graphic organizer. I like it a lot. So let's see how we can use it to summarize all the statements we've learned. We first started with 2 categories. If you recall, we had compound statement, right? And then today we learned a conditional statement. So in compound statement, there's 2 subcategories. One is conjunction and one is disjunction. So let's see how if we recall any of these. We are given 2 statements here. P, vertical angles are congruent. Q, 15 is a prime number. So a conjunction is simply you're putting the 2 statements together and you use the word and that little hat represents and. So you say P and Q, sorry about that. So you say P vertical angles are congruent and 15 is a prime number. And this obviously is false because in order for a conjunction to be true, both statement has to be true. In this case, vertical angles are congruent is true, but 15 is not a prime number. And disjunction is, if you recall, is P or Q, and that or is really important. And so to make a disjunction statement, we say vertical angles are congruent or 15 is a prime number. So in this case, again, this part is true, second part is false. However, because of the letter or, the word or, one true statement is enough to make a disjunction true. So that's a review of the first half. Second half, we covered conditional statements. And here we have 2 statements here again. Statement P says it's St. Patrick's Day, and statement Q says it is March. So let's look at some examples here. I'm going to move this down a little bit. Okay, so that we can see this. There we go. So we learned four, is it four? Yeah, we learned four different conditional statements here. So first one, conditional statement says, if P, then Q. So we say, if it's St. Patrick's Day, then it's March. And obviously this is true because both are true. The inverse means it's just the opposite, not P, then not Q. So if it's not St. Patty's Day, then it's not March. So you're negating both statements, and in this case, obviously, it's false. And the converse is simply swapping the P and the Q. So if Q is true, then P is true. So we say if it's March, then it's St. Patty's Day. In this case, it's also false, right? And contrapositive is the one that needs to combine the inverse and the converse, which is if not Q, then not P. So if it's not March, then it is not, sorry about that, it's not St. Patty's Day. And obviously, this is true, right? Finally, my favorite is the biconditional statement. And the biconditional statement is, the key word is if and only if. So P is true if and only if Q is true. So in this case, we say it is St. Patrick's Day if and only if it is March. And for biconditional statement, both has to be true. So in this case, it's false. Okay, so that's a graphic organizer that summarizes the entire unit. Make sure that you understand every single one of them and reference it back to your notes. And if you have questions, I will see you in class. Thanks, guys.